Okay, this is Simplifying Ratios, the second video, and we finished the first video with example 2, where you were using conversion factor, using your measurements, minutes to hours or kilograms to grams, and converting those. And we talked about how the conversion factor is always equal to 1, like 1 foot is 12 inches. So I'm going to give you, and here, right here, you've got your turn, question 2. I want you to convert 1,250 centimeters to meters. Now, one thing you probably don't know right now is how many centimeters are there in a meter. So this is something that you can research. Just Google that or look it up in your book, or you may know that conversion, but do a little research. That helps you to remember that later, how many centimeters are in a meter, and then convert this question. All right, hopefully you paused the video and you tried this problem. So let's go through what you should have done to answer this question. Now, what we've done on the other problems, we've looked at what units we have and what units we need, and we know that we need meters. And like I said before, you need to know how many centimeters are in a meter. And we're going to start with our original measure here, which is 1,250 centimeters. And we want to convert that to meters. So what we talked about in the last video is how we have to have common units to divide out. And since we have centimeters, we want centimeters here in the bottom of our fraction so that these two easily divide out. Hopefully you looked this up, but there are 100 centimeters in 1 meter. So 1 meter is 100 centimeters. If you think of century as 100 years, centimeters, they have the same prefix, is 100 centimeters in 1 meter. But what we have here is we have our common units that we can divide out. We have our centimeters that divide out. And what we have left over is meters, which is what we were looking for. So we can go to our multiplication problem here. We have 1,250 times our fraction 1 over 100. So you could type that in your calculator, 1,250 times 1 over 100, and you will get 12, let's change back to the pen here, you will get 12.5, and then we bring our units that we need down, meters. So 1,250 centimeters is 12.5 meters. Now hopefully maybe a shortcut that you see here, even though we're multiplying by this fraction 1 over 100, that's the same thing as saying 1,250 divided by 100. This here, the 1250 times 1 would be your numerator, and your 100 is your denominator, so you may see a shorter path there than multiplying. You could actually divide in this problem. But converting measures, make sure if you don't know how to convert as far as the units, then you need to research that, and then always try to find where you can divide out common units. Now we're going to look at the next definition is unit analysis or dimensional analysis, and we're going to use our units. We've been doing this throughout the last couple examples where we actually use the units to determine our units for our answer. Okay, so our units are in our calculations. So we got a word problem here for example 3, and what you need to do when you're reading this word problem, when you're thinking about it, pull out or highlight or underline the important information, and then actually pull that information from the word problem, rewrite it if you need to, so that you can see it and not all the extra things within the word problem. So what we have here, we have the CN Tower in Toronto, Canada is about 1,815 feet tall. So what I know, first off, what should be kind of cluing into me is I know how tall this building is, and we're talking about feet. So I know the height and I know the units. Then it goes on to say about how many meters tall is the tower. Well, it says about how many meters tall. So that should be cluing into you. I know how tall my building is in feet, and my question is asking me about meters. Okay? Now, the one nice thing about this example is that they have given you the conversion factor here of 1 meter is approximately 3.28 feet. So that's nice. It's not something we have to go looking for. They've given us that. So let's just start this problem off the way we've done the last couple of examples. We know 1,815 feet. That's what we know. That's what they've given us. And what we want to know is to convert this to meters. We want to know how many meters does that represent. Well, in all the other problems, we've looked for places or ways that we can divide out common units. So what I want to do is I'm going to multiply this by some type of fraction here so that my feet, my units in feet, can divide out and I'm left with meters. Well, that's what I've got highlighted in blue here, what they've given us. 1 meter is approximately 3.28 feet. Now, we want our units in the denominator here so that they divide out. So feet needs to be the denominator, and then we have our 1 meter in our numerator. So all we're going to do here is multiply. So we can go ahead and divide out our common units. Again, we have our meters left over, which is what we needed. And we have 1,815 feet times, or actually, excuse me, 1,815. We no longer have feet. We've divided those out. 1,815 times 1 over 3.28. Now be very careful whenever you're typing this in because you do have a decimal there in your denominator, so don't forget that when working this problem out. But if you go ahead and multiply that, you will get a decimal. So let's approximate. This symbol here means approximately 553 meters tall. I'm going to finish this out since it is a word problem. Our building is approximately 553 meters tall. So what I want you to do now is I want you to pause the video and I want you to try the Your Turn Example 3 here, which is basically the exact same type of problem, and see if you can convert from feet to meters. Alright, hopefully you've worked this problem out, and it should not have taken you very long, really. This problem is almost identical to the last one. What they've given us is a building that's 1,450 feet, and they've asked us to give them the measure of the building or the height of the building in meters. So exactly the same thing as the last problem. They have even given you again here that 1 meter is approximately 3.28 feet. So, should have set this problem up exactly like the last one. You've got 1,450 feet times, and then if we want our feet to divide out, just like the last problem, we want to make sure that our units in feet is here in the denominator. So our 1 meter would be in the numerator. So hopefully what you did from there is you divided out your common units, which leaves you with your meters like you needed. And then you have 1,450 times 1 over 3.28. So if you go ahead and multiply that, you should have gotten approximately, because you do get a decimal, 442 meters tall. Being able to convert based on that word problem. So our word problems are going to get a little more complex. Let's look at this next one. We're still going to have to use the dimensional analysis, your unit analysis. We've got to make sure that we have our units within our calculations, because this one's actually going to be a little bit more difficult. We've got different units, more units, I guess I should say, in this problem than we did in the other. If you start reading this question, this problem, the very first sentence tells you that a student ran the 50-yard dash in 5.8 seconds. So what this sentence is telling me, what I am seeing when I read this sentence, is I actually have two different units here. I've got 50 yards, that's how far the student ran, and I've got 5.8 seconds. I have two different sets of units here. So what my brain is telling me is that I'm probably going to have to change yards to something else and seconds to something else, since I do have two different units. So if we go ahead and read through the problem, at what speed did the student run in miles per hour? All right, well, let's think about that. The distance he ran was 50 yards, and they want us to change that to miles. I'm going to highlight this in yellow also, because these are my two distance units. I am in yards, and they want us to go to miles. And they want us to do miles per hour. So we've got seconds in pink up here. So I'm going to highlight hour in pink. We've got to change seconds to hours. All right, and we know that there are a lot more than 5 seconds in an hour. So this is going to be a fraction of an hour. And this is going to be a fraction of a mile, because we know that we should know, hopefully, that there are a lot more than 50 yards in a mile. So let's see how this is going to look when we set this up. We're going to take what we know for sure. We know 50 yards in 5.8 seconds. So we've got 50 yards, and again, dimensional analysis, use the units in your calculation. 50 yards in 5.8 seconds. And again, we want to change this to miles per hour. So let's focus on what I have highlighted in yellow first. Let's focus on changing yards to miles to begin with. So just like we did on the last part, we could kind of forget about our 5.8 seconds for just a minute. Just like we did in the other problems, let's multiply this by the correct ratio here. Well, one thing you have to know, I've got to change this to miles, and I've got to get rid of the yards. So that means if I want to be able to divide out my common units, yards will have to be on the bottom, and my miles are going to have to be on the top. So you have to know, well, how many miles are in a yard, or how many yards are in a mile? Okay, well, you've got to think of what's my least units, or the units that are going to be the smallest. Well, that's actually going to be miles. 1 mile, this is something you could research, is 1,760 yards. Okay, so this is going to make this easy. I'm going to be able to divide out my yards here, which is what I want to do, and I'm left with miles. So now let's think about our seconds. Okay, well, I need to get rid of seconds just like I got rid of yards, but this time my seconds are actually on the bottom. So to be able to divide those out, my seconds are going to have to go to the top. And they want this in hours. All right, so we have to think, well, how many seconds are in an hour? This one should be a little bit easier. In 1 hour, there are 3,600 seconds. And so now you can see where my seconds will divide out. Okay, so now all I'm left with is hour, like I needed, and miles. So knowing how to multiply fractions, you all learned this in middle school, you need to just multiply straight across. Multiply straight across. So 50 times 1 times 3,600 will give you 180,000. And our units on top is miles over 10,208 hours. But we want this in units of 1. We want to know miles per hour, 1 hour. So go ahead and divide those, and you're going to get approximately 17.6 miles per hour.